Good day, ladies and gentlemen. Okay, we're going to have a quick chat about this idea of modulo arithmetic. In this short video, I'm just going to quickly explain what it is and how to calculate it, and then we'll go on and use it in our cipher algorithms later on. So first of all, what is it? Well, cast your mind back to when you were learning maths back in prep school, or junior school. You will have learned something like this. 16 divided by 3. So, how many times does 3 go into 16? Okay, well, it goes in 5 times, and there's a remainder of 1. And then you might have learned something like this. How many times does 3 go into 17? Okay, well, 3 into 17 goes 5 times, but this time there's a remainder of 2. Then you might have learned, okay, 3 into 18. Well, 3 into 18 is going to go 6 times with 0 remainder. Okay, so how does that relate to modulo? Well, this number here is actually the modulo. And in Python, we use the percent symbol for it. So if I were to write 16 mod 3, the output of that is going to be 1. And if I were to write 17 mod 3, the output of that is going to be 2. And if I write 18 mod 3, the output of that is going to be 0. Okay, so that's all great, but there's also an interesting property about the modular. If I write out a series of numbers, if I write out from 0, 1, 2, 3, okay, and now I'm going to find the modulo of each number. So each number divided by 3. So each number mod 3. Okay, so let's make it easy. Let's start with 3. So 3 mod 3 says how many times does 3 go into 3? Well, it goes into 3 times, exactly 1 time, remainder 0. And then how many times does 3 go into 4? It goes 1 time, remainder 1. How many times does 3 go into 5? It goes 1 time, remainder 2. And then 6, it's going to go 2 times, remainder 0. 7, 2 times, remainder 1. 8, 2 times, remainder 2. 9, 0. 10, 3 times, remainder 1. 11 is 3 times, remainder 2. And then how many times does 3 go into 2? Well, it doesn't go in, but so there's a remainder of 2. And then how many times does 3 go into 1? Well, it's 0 times, and there's a remainder of 1. And then 0 gives you a remainder of 0. Okay. So you'll notice that there's a pattern forming. 0, 1, 2, 0, 1, 2, 0, 1, 2. And this is why we use the modular. So what the modular allows us to do is to go from any number or any sequence of numbers, so 0, 1, 2, 3, 4, etc., and then map that sequence of numbers onto a different pattern, 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay? And it's that ability then to map any sequence onto this pattern that makes the modulo so useful. And we'll talk about that when we start talking about our encryption. The last thing to note is that this pattern is 0, 1, 2. What if I wanted a different pattern? What if I wanted 0, 1, 2, 3, or 0, 1, 2, 3, 4? Well, that's easy enough. I can just change my modulo number. So if I take 4, How many times does 4 go into 4? Okay, well, 4 goes into 4 one time, remainder 0. How many times does 4 go into 5? One time, remainder 1. 6, one time, remainder 2. 7, one time, remainder 3. 8, two times, remainder 0. So you can see now I'm getting a different repeating pattern. 4 into 9, 2 times, remainder 1. 4 into 10, 2 times, remainder 2. 4 into 11, 2 times, remainder 3. So now I'm getting this 0, 1, 2, 3 pattern. Okay, so if I want the numbers to go between 0 to 2, I can use mod 3. 0 to 3, I can use mod 4. If I wanted to go between 0 and 9, I could use mod 10. Okay, so that's the mod arithmetic. What we'll talk about next is how do we use this, or one of the ways in which we use this when we're doing things like a Caesar cipher. Okay, any questions? Let me know. Other than that, look forward to seeing you all soon. Take care.